Hello, everybody, and welcome back. Root Beer here, looking at question 10 on our Ontario Senior Mathematics Problems competition. So what do we got? In a school made up of B boys, T athletic teams are formed. The athletic director puts K boys on each team and arranges that every boy plays on the same number of teams. It's looking like a sort of a combinatorics counting problem. He also arranges that every pair of boys play together the same number of times. Okay. Find out how many teams a boy plays on and how often two boys play on the same team. Okay. So I don't think this is going to be too hard. It seems sort of like a very basic counting problem, similar to something you might find in introductory graph theory or, you know what actually it reminds me of? Kirkland... the Kirkland School Go problem or Steiner triple systems or something like that, where you have actually I think there was something like this in the 2019 or maybe 2018 Euclid or something like that. Anyway, the questions like this come up a fair bit. So well, let's see if we can talk our way through it. So we know there are B boys and we know there are T teams. Now, there are T times K boys playing on teams overall. Obviously, some are repeats. Right? We only have B boys to go around. But this is the total number of boys on teams, counting duplicates. So if every boy plays the same amount of times, if each of B boys plays on the same number of teams, I don't know, call that M for team. Then there are BM boys playing overall, but we already know how many boys there are playing overall. TK is equal to BM, so just rearrange TK over B is the number of times a boy play or the number of teams a boy plays on. Okay? So you've got the total number of boys counting duplicates, divide by the number of boys you've got, and then you have the number of times that boy is duplicated. Being duplicated just means he's playing on another team. Okay? So there we go. I think the same sort of reasoning should work with pairs. Okay? But there's a sort of different way to count the number of pairs. So there are T teams, each with K boys. Now, how many pairs are there on each team? Well, we can use a little bit of combinatorics language that we've already seen choose notation in question 6, was it, I think? So we're comfortable saying this. Out of K boys, choose 2. That's how you make a pair. So there are K choose 2 pairs per team. So there are T, K choose 2 pairs overall. All we're going to do is count the number of pairs of boys a different way. There are B choose 2. There's B boys. Choose 2 of them. You've got a pair of boys. If each pair plays together, let's say P for pair many times, or R, because we used the last letter of team because T was already spoken for. Yeah, let's say R, just to be mildly consistent with ourselves. So each pair together plays together R times. And then there are, so the number of pairs of boys and the number of times that pair appears, as opposed to the number of teams and number of pairs on a team, but these two numbers are the same. And that's what we're arguing here. So T, K choose 2 is equal to B choose 2, R, and we just want to solve for R, so R is T, K choose 2, E choose 2. I'd accept that as an answer, but I don't want to go digging through the solutions to see what they've got. So I'll just write out the expression here for choose notation. And, I mean, all we can really do is cancel out the 2's. So TK, K minus 1, divided by B, B minus 1. We don't have enough information to cancel anything else. Okay? And, I mean, the same reasoning should work for triples of boys. If you know for a fact that the coach has arranged for the same triplet of boys to play together the same, or every triplet of boys to play together the same number of times, you do the exact same reasoning. Number of teams, number of triplets on a team, number of triplets of boys individually times this fixed number that they all play. And it's because the coach has done this arrangement we know these equations have to be equal. That the number of pairs counted in the 2 different ways is equal, or the number of boys counted in different ways is equal. Okay? But I think that should be it. So that takes care of question 10. I'm just going to double check there wasn't anything else, was there? Find out how many teams a boy plays on. Well, we just have to do it in terms of B, T, and K. Those are the only values we're given. And find out how many teams a boy plays on and how often 2 boys play on the same team. Yeah, that's what we were asked. I think to go a step further, a question might say, what conditions on B, T, and K allow the coach to arrange for every pair of boys to play the same time? But we're not asked for that. So we get to sort of assume that these calculations will work out and they will produce integers, that B and B minus 1 are factors of T, K, and K minus 1. Okay? But there we go. A nice little combinatorial counting question. And let's get ourselves a fresh sheet of paper for question number 11, and we'll take a look at that in the following video. Take care and have a wonderful day.